The definition of slope is rise over run. And in mathematics, when we have a line in a coordinate system, we define that slope to be the difference in the y's over the difference in the x's, which gives you the rise over run. In this case, I took 7 minus 2, which is the difference in the y's, and put it over 6 minus 3, which is the difference in the x's. And that gives me 5 over 3. Now it wouldn't matter which order I did this in. For example, if I write the A on top and the B on the bottom, I still get the same result. You notice I get a negative 5 on top and a negative 3 on the bottom, but that results in the same fraction, 5 over 3. When the line rises from left to right, you always get a positive slope for the line. Here's a line which falls as you go from left to right, and you notice this time when I do rise over run, or the change in y over the change in x, it results in a negative value. I get 2 over negative 6, which can be reduced to negative 1/3. Once again, if I had written the b on top, I find it very useful to write them lined up like that, because then the y's line up and the x's line up. This time I ended up with a negative 2 on top, but again you see I get a negative 1/3. You can think of the negative either being a negative rise, in other words going from A to B, we come down 2 and then across 6, or if you're going from here to here, you go up 2 and then 6 to the left. So either way you do it, you're going to come up with a negative for your slope when the line is coming down. Now, one of the things that we want to do when we're working in a coordinate system is come up with an equation for that line. I've marked several points on this line and also a general point up here, and I'm going to develop the equation of this line without using a formula. In the next video I'll look at y equals mxp and one of the other formulas used for getting line equations. But I just want to show you that if you work out the slope of this line, you can use any of these 2 points that you want. I happen to use 6, 7 and 2, 1, and I got a slope of 3 over 2. Then I used the general point, the xy point, and again 2, 1, could have used any of the other points, and I again wrote down the slope. Difference in the y's is y minus 1, and the difference in the x's is x minus 2. Now that slope has to equal the 3 over 2, because that's the slope of the line. When I write the two together, that's what it looks like. The two slopes are equal. I do something here called cross multiplying. I'm actually multiplying both sides by 2 and by x minus 2, but the shortcut is to just cross multiply with the denominators. Get rid of the brackets by multiplying the numbers in. Then I moved everything to one side. I happened to move it over here because I wanted to start with a positive 3x. Brought everybody over, and that's what it looks like. Now, just to relate it back to some of the work you may have done in class, you may have talked about y equals mx plus b, which I'll do in the next video. But I just want to show you, if I rearrange this equation, brought the 2y over here, divided both sides by 2, y equals mx plus b. The m slope, 3 over 2, which is what we worked out up here, and the y-intercept is negative 2, which we can see right there. So that's working out an equation without actually using a formula. In the next video, I'll talk about y equals mx plus b and also the point slope form.